All right, so today, what is today? The 13th. I'm going to do a super fast version of what we did, bell work, and then just some real quick sort of review things or things that just came up during IXL practice during class. I don't have a class in here right now, so I'm going to go through it super fast. You can always pause it if you need to. So we're still doing the three-dimensional figures, and we're focused on surface area and volume. So I'm not going to do the vocabulary that was in the last video from last class. So I'm mainly focused on how to solve for surface area and volume. If you are using formulas, which you will be for some of them for sure, if you're using the formulas for surface area and volume, you've got to use the best standards reference sheet formulas. Do not use the book formulas. The book formulas give you more information than you're going to get sometimes with the best standards formulas. And that's what you're going to get on my quiz or on the district quiz tests or on the EOC. So I'll write the formula up that's from the reference sheet. If it doesn't match up the one you're using, then you're probably using the book formulas and you need to use the one that I write up. If I even use a formula. I'm not going to use a formula for some of this stuff. So for surface area, this was the bell work, by the way. So for surface area, I'm not really going to use a formula a lot of the time when I do surface area. The only time I really use the formula would be for a cone and sort of for a cylinder. But if it's some kind of a prism where all of the sides are flat, all of the faces, the bases, the sides, whatever you want to call it, everything's flat. I don't use a formula. I just figure out what is the area of each side, and then I add all of the sides up. That's what surface area is. It's the shell, we said, or the outside, or the wrapper, or whatever you want to call it. Like if you wrap a present, the wrapping paper is the surface area. How much wrapping paper would you need? That's basically what surface area is. So I just need to figure out what is the area of each side, each face, including the bases. And then I need to say, okay, well, once I find the area of all of those, I add them all up, and that's the total surface area. So for example, if I have this figure, 6, and then say that's a 4, and say that's a 5. I want you to try to figure out surface area first for that, and then you can go ahead and try to do volume also real quick. Volume's a little different. That's kind of a specific formula, sort of, but I'm going to also give you another intuitive way to think about volume, so maybe you don't always need a formula for that. So go ahead, pause it, try to do both of those. I'm going to go ahead and keep going so you can unpause it when you're done. So when it comes to surface area, again, I just want to know, one thing I will do is I typically will write in the measurements of the other sides that I see. If this bottom side is 6, this top side is 6. If the height over here is 5, then the height over here would be 5. This we would call the width for the bottom side, the bottom base. And then we would say this would also be 4. Get rid of the circles. 5, just 5, 5, and 4, but no circle. There. So if I want to think about surface area, I have 6 sides to this rectangular prism. I'll talk about the bases in a second, but remember the definition for a prism, the definition of the base is the 2 parallel sides. And they will typically be a different shape than the other 4 sides when it's a rectangular prism. Now, in this case, I probably haven't drawn the best example because I think the book uses more regular prism shapes where all the faces are the same side except for the 2 bases. I've got 3 different size shapes. They're all rectangles, but all those rectangles are different shapes. I mean, it's still the same concept. I don't think the IXLs do that. But regardless, what I do is going to apply to everything. But if you happen to notice that you're normally getting more sides that are the same shape, that's because the book does it with regular size shapes. Regular means all the sides are the same length. All right, so all I really need to do is identify, first of all, the different size rectangles. So this is one rectangle right here, right? That's one rectangle. I then have another rectangle in front. That in a different color. And then I have a rectangle that is the top rectangle. Doing a pretty good job of coloring until that right there. Went outside the lines. So there are my three visible rectangles. But I need to also remember that for the green rectangle in the front, there's also an exact duplicate rectangle that's on the back side of this prism. For the yellow rectangle, there's an exact duplicate on the left side of this prism. And for the blue rectangle, the top base, there's an identical base on the bottom that has the same exact area. So there's actually only really three different sizes. And then for each one of those, we have an exact duplicate on the opposite face. So if I want to figure out surface area, and again, we said surface area is just the area of all of the surfaces added together. I know how to figure out the area of a rectangle. I don't need to look at some formula on the reference sheet. I'm just going to figure out the area of each of these rectangles. I'll have to either multiply that by 2 or add them twice or something because, like I said, there's 6 sides, not 3. So if I want to figure out the area of the yellow rectangle, that's just 5 times 4. Length times the width, I guess I could write that. Length times width is the formula for the area of a rectangle. So 5 times 4 equals 20. So I know the area of that yellow side is 20. Well, if I know the area of that side is 20, I know there's a side on the far left that's opposite that is also the same exact side, and therefore it's 20. So I've already done 2 sides now. Now I can look at the top and say, okay, well, I know the top length times width is 6 times 4. Well, that equals 24. Well, if the top is 24, I know the bottom is 24. So I have those 2 that I can add in. And then last, but certainly not least, the front is 5 times 6. So that is an area of 30. Again, if the front is 30, there's a back side that is the exact same area. So I can add in 30. That's my surface area. I didn't need a real complex formula with perimeter and all this kind of stuff. I just figure out the area of each rectangle and add it all up. So if you do add it all up, it comes out to be what? 60 plus 40 is 148. That's what you should have gotten for surface area. And if you use the formula, that's fine. You just need to make sure you're coming out with the right answers. Now for volume, and I'm going to try to give you an image. I can't really, I did this in person in class. It's a little tricky though to do in only 2 dimensions on the screen. I had a 3-dimensional thing I used in class. If we want to do volume, you could sort of think as volume as having a square on the bottom. God, how can I do this visually on a 2-dimensional screen? It's going to be tough. So try to imagine this. Try to imagine that you have a square. What's a good square? Tell you what, this isn't perfect, but we're going to use phones. Imagine phones. Everybody knows what a phone is. It's a rectangle, right? So your phone has an area if you just take the length and the width and you multiply them together. That's the area of a 2-dimensional object. Technically, your phone is not two-dimensional because it already has a little bit of height to it, because if you lay it down flat, is raised up off the ground. But just imagine it's just a two-dimensional thing, and you just multiply length times width, and that's the area of your phone. Now, so again, length times width would be the area. So let's say it's 4 times 2. Draw another picture. Actually, here, I'm just going to change this. So let's say it's 4 times 2. So the area is 4 times 2, which is 8. Now imagine if I was trying to do volume. We said volume gives the third dimension of height. We are taking something that's flat and we're giving it height so that we can fill it up. We talked about a circle being a flat bottom or a flat base, but then if we want to make it into a bucket, we just add sides going all the way up. So now it's a three-dimensional figure. It's a cylinder. But we started with a circle and then we just went straight up and we added sides. So for a box, we start with a rectangle and then we just add sides going straight up from all the sides of that rectangle. Well, if I did sort of that same thing with a phone, so let's say this is my phone that I just did with a area of 8. If I keep stacking phones that are the exact same size on top of that, and I keep stacking it, so again, the area of my bottom phone is 8, and then I stack another phone. Oh, boy, it's going to be hard to draw. I stack phones on top of each other and they get higher and higher and higher. Every time I stack, oh, those are all supposed to be the same height or same size. Every time I stack another phone on top of my original phone, I'm adding an area of 8. So I'm adding an area of 8 every time I put a new phone. Well, that's basically all volume is. It's just taking the area of the base and it's adding that same area every time you add one on top of another one. So basically every time I add height, I'm just multiplying however high it is times whatever the area was for the base. So if you look at the formula for volume, that's exactly what it is. It's the area of the base and then times the height. So again, if you just imagine, okay, well, what's the area? How many of those am I stacking up? Or basically, how high is it? That's the formula for volume. So you don't, I mean, you don't have to memorize it anyway because you get the reference sheet. But if you intuitively think about it, it'll also help you maybe solve it sometimes if you're struggling to kind of figure something out about the figure, maybe. So anyway, for this particular rectangular prism, we would say, okay, well, if I'm sitting on, so the blue is the top, we'll say the 24 then is also the bottom, so the base. So my area of my base is 24. Again, if I just think about stacking that area up, my height is 5. So I'm using this number here because I'm stacking that bottom base, I'm just stacking up and it's getting higher and higher and higher. And I would then multiply it times 5 and I'd get 120. Now, I don't know if anybody's thinking this to themselves, but I will tell you, I said the other day, when we look at a figure, that sometimes we have to think about the figure tilted on its sides. So I told you really that the base for this figure, it's not really necessary the bottom and the top are the bases, especially if they were all the same side. I told you the left and the right were the bases. I said, well, you kind of have to think about it standing straight up instead of laying flat like this. So you might be saying, well, wait a minute, how could that work if the base is 20 instead of 24? Well, you just would change the height. If this were standing more vertical and it was standing up on the side that's 20, that would mean that would be the base, 20 would be the base, but now the height would be this number, the 6, because that would be the side that would be straight up and down. Well, you'll notice if I take that same formula and if I use a base of 20 times a height of 6 this time, because now I'd be standing this figure straight up and down, I still get the same answer. I still get 120. So this is by far the easiest shape to do volume on, or even really surface area. it's kind of my bare minimum expectation for you to get a passing grade is that you can do this particular type of problem for surface area and volume. And the reason is because you can actually kind of not completely understand it and still get the right answer. But anyway, that's a few different concepts all in that same problem. The last thing I'll mention has to do with a cylinder. We'll just move on. I think I have a picture of a cylinder. So yeah, so if we have this particular cylinder, the base would be this bottom and this top. That would be the base. The height would be this side right here. Even if that figure were tilted on its side, so even if it looked like this, you have to understand the height is still this line that connects the two bases, even though it's tilted on its side. So if they give you a line like this, that is not the height. That's actually the diameter of the base. We said diameter is a line all the way across a circle. The radius is from this center point out to the edge. So that's the radius. The height, though, is still this line down here, the side that connects the two bases. So that's one thing they could possibly try to throw a trick at you on, like the district test or something. Again, we could still use the same principle for volume. We could say for volume, well, if I just know the area of this base, and then if I stacked a whole bunch of circles, like think of pennies, basically, if I was stacking circles on top of each other for the volume, every time I stack another circle, I'm just going to add that volume to my whatever my area of that base is. So if the area of that base, and I'm not going to do a whole problem, but let's say the area of the circle on the bottom was 10. Well, every time I stack another circle on top of that circle, I'm adding another 10. So again, the area or the volume of a cylinder is just the area of the base times the height for that reason. I'm just stacking 10 plus 10 plus 10 plus 10, and the height is how many times I stack that up, basically. We did the example problem the other day of a cone and doing surface area and volume, so I'm not going to do that one again. I think I'm just going to jump into doing what you need to know sort of for the IXLs. So in a pyramid, really just a I guess it's for a triangular pyramid or a rectangular pyramid. You need to understand that this slant height, so that HS is the slant height. Well, that's not a very good job of it. There, that's slant height. The slant height refers to that black dotted line. The normal height refers to this dashed blue and now blue and green, I guess. Well, depending on what I'm solving for, sometimes the slant height I'm going to actually use is just a normal height. For example, if I wanted to do surface area, I told you that I could do surface area by just taking the area of every one of the sides, every face and the base, and then adding all those areas up. So for this particular figure, I have 5 sides. I have the base, which is a rectangle or probably more likely a square normally. And then I have all the triangles that go around the pyramid. And all the triangles are going to be the same side typically. If I just found the area of the base, I just found the area of this base. Boy, I may not be able to do this with highlighter here. The area of that base. So that would be one area I would need. Then I really just need the area of one triangle because I have 4 triangles that have the same area. So if I then found the area of this triangle here, we'll say, oh boy, how can I do this? I guess I'll try to do the highlighters. So if I then found the area, oh no, sure. Nope. Apparently green. Oh, there we go. That wraps over. If I then found the area of that triangle there, well, whatever the area is of that triangle, I just multiply that times 4 because there are 4 triangles that are the same size all the way around. That would be my surface area. Well, here's the tricky part. The area of the base is easy. That's just length times width because it's a square, really a rectangle, but most likely a square. If I'm going to do the area of this triangle that's kind of in purple and it overlapped in black, I'm going to get rid of that because I can't really see it there. So that triangle that I just had shaded. If I want to do the area of that triangle, it's a little weird, but hopefully you will get used to it as you practice more. I need to have the base and the height for that triangle. That's the formula for area, 1/2 base times height. Well, the base is just this side right here. That's the base. So it's really whatever the width was of the bottom side of this figure. So again, we have the base, which is the rectangle, but then we also have the little b, which is the base of that triangle. So whatever the base, that's not a 6, that's the letter B. So whatever that base is, whatever that length is there, the W value, that's the base of the triangle. Then for the height, so for this part of the formula, so we just said this B goes to whatever that width is. For the height of that triangle, it's actually whatever the slant height is, that black dotted line. Because if you think about this as just the triangle itself, like ignore the fact that it's part of that pyramid. If I'm just looking at that triangle right there, so ignore all of this. So if I'm just looking at that triangle, well, now that black dotted line is just the height of that triangle. It goes from the vertex of that triangle up top all the way down to the base, and it would be a right. Oh, I didn't mean to do that. I mean, I did, but I didn't want it to do that. So the bottom intersection is a right angle. So that black dashed line is the height if we're dealing with this formula. So it's the 1/2 times the base times the height, but the base becomes the whatever value that W is, and the height becomes the slant height of the overall pyramid. I know that's confusing, just practice it a lot. Again, if you use the formula for that, it uses the slant height already. I think it uses perimeter instead of the base, maybe. Yeah, it uses perimeter. So if you want to use that formula instead, again, I'm just not big on formulas. I'd rather you understand how to come up with surface area. But if that's too confusing, you can just use the formula for a regular pyramid for surface area, which is base. So the area of the base, which should be pretty easy to figure out. It's just length times width plus 1/2 times P, which is the perimeter of the base, and then times the slant height. Or you could replace the H of S. They sometimes, remember, they use the letter L, the cursive L, or it's not always cursive, I guess. So you could use that formula instead. So I am not going to work out any problems on that. We'll probably do that next class. That's the quick version of the lesson from today, though.